Hello friends, today I am going to discuss one of the most important topic called polymer. Here we are going to discuss the basics and fundamental of polymers in a most easiest way. Now in this video, what are the things we are going to cover? Okay, which really help to understand the polymer in a very easiest way, so that we can remember for a long time, we can write the answer in the exam in a proper way. So what is there? So you can see that today we are going to discuss the polymer. In the polymer, the first point we are going to discuss about the definition of the polymers, where we are going to discuss about the monomer, polymer, and also a bit of functionality. Then we are going to discuss the second point, that is called degree of polymerization, like how many monomers join together to give the polymer, we are going to discuss. And in the third, which is most important among the all, how to calculate the number average molecular mass and weight average molecular mass. We are going to discuss them, and we are also going to have one or two quick numerical. In the fourth point, we are going to discuss the ingredients, the additives of polymers which is required to give a proper end property. And it is also known as the compounding of plastic, we are going to discuss. In the fifth point, we are going to discuss that what is the effect of temperature on the polymer, because polymer consists of several different polymer chain. If I am going to increase the temperature, how they are going to behave, we are going to discuss in that segment. And in our last point, we are going to discuss quickly onto the conducting nature of the polymers. Everything, all the topics I am going to discuss, as I said, in a very fundamental way, so that everyone can understand in their own way. So let's start with the definition first. Now let us start the definition of the polymer. We know, many of us know what is the definition of the polymer, but still, because we are stated that we are going to discuss in a very easiest way, let's start with the definition of the polymer very quickly. Now see, there are many monomers. Okay, let's say there are many monomers when joined together. When many monomers joined together, then it become a polymer. Okay, so this is the, you can consider the definition of the polymer. Mono means one, mer means molecule. When a single molecule or many single molecule join together, I can give you an example, real example. You can see CH2 double bond CH2, okay, one CH2, then another CH2 double bond CH2, another double CH2 double bond CH2. Now you can see there are so many monomers. They are the monomers. Now how they are joining? They are joining by opening up one of the bonds. Now you can see they are making a bond, and now they become a polymer. So this is how a polymer formed. When many monomer join together, they will give a poly. Poly means many. So many or single molecule join together to give a polymer chain. Okay, so this is how the polymer is formed. Now here is a question is come, like monomer, can any monomer form a polymer? Right answer is no, and that is called functionality. The monomer we are considering which contains the two or more functional group or reactive side, then only they can form a polymer. Let me repeat when I said, when the monomers contains two or more reactive side, then only they'll form the polymer. Let's have a quick example. Like I have three monomer, CH3 single bond CH3, CH2 double bond CH2, and CH triple bond CH. Are all of them going to be like we have a monomer? क्या सारे मॉलिक्यूल मोनोमर होंगे? राइट आंसर इज नो, बिकॉज दिस कंटेन्स फंक्शनल group, but ethane does not contains any functional group. I can show you that. Now look at here, these molecules can break up this bond and form like monomer like this. Okay, for this one, if I draw, you can see there is two triple bond. So one bond break like this, another bond break like this. So it can form CH single bond, one function, this one. So it can form the polymer in a two-way. So this we need to know that क्या कोई भी मोनोमर बन सकता है? राइट आंसर इज नो. मोनोमर शुड हैव at least two or more functional group or functional side or reactive side, then only they can form the polymer. That is called functionality. So now we're going to discuss our second point, and that is degree of polymerization. Okay, now going ahead, the story of polymer. We said when the monomers join together give you polymer. But the second question coming, like how many monomers can be joined? Is there any fixed number or is a variable number? The right answer is it may be any number. There is no fixed number for the polymerization, and that is the reason, because we are having different monomer or different number of monomers when joined together give a polymer. So polymer will have different molecular weight. We are going to discuss very soon, but before that let us talk about this topic, degree of polymerization. What is the definition in one line? It is the average number of repeating unit. So how many monomers repeating joined together give you polymer? Quick example. Now consider n number of CH2 double bond CH2 molecules. This is monomer, mind you. This is monomer. Okay, this is monomer, n number of monomer. When joined together, they will form CH2 single bond CH2 whole n. This is polymer. Okay, and the common name is PE, polyethylene. Okay, polyethylene. So that is the polymer. Now what is the important of this topic of degree of polymerization? Based on the value of n, the molecular mass of the polymer depend. Means how many repeating unit? Suppose 10 monomer joining together and 100 monomers joining together are not same. 10 monomers when joined together give you low molecular mass polymer, but when 100 monomers join together they will give you polymer with very high molecular mass. We are going to discuss. Now consider the mass of the monomer is m0 and mass of the polymer is capital M. Then what is the relation between the two? The relation is capital M is equals to N into M0. Now what is here? N is the degree of polymerization. Okay, n is the degree of polymerization, and that's what we said in the definition, the number of the average number. You can see this is the number. Okay, this is the n is the number, how many numbers or how many monomers joined together they will give you the form the polymerization. For your quick information, m0 is the molecular mass of monomer. Okay, M is the molecular mass of polymer. You can note it down as a notes. So this is the degree of polymerization, and now we are going to talk about our third one, and that is very, very important and crucial in this video, that the calculation of average molecular mass. So now in the continuation of our previous discussion, we just understand that different number of monomers joined to give a polymer. It means when it's come different number, you can understand we can have the polymer chain of different molecular mass, because polymer chain can give you of different polymer chain length. Now since this is the kind of polymer chain combination happen, Okay, you can see that polymer chains with high polymer chain, they are having shows more molecular mass. Okay, the polymer with shorter length give you less molecular mass. So we need to calculate it. We need to take the average. Now here we all need to understand that when we are taking the average value, many of us, in our daily life, we are talking about the average term, but we don't know the exact definition of the average. When for the same thing, we have to have several values. For the same parameter or same event, we have different values, we have to take the average. Here also you can see we are only bothered about the molecular weight of polymer. We are only bothered about the molecular weight of the polymer. So that is the single event. Now you can see for that we have several values. That is the reason we have to take this one average term. Now molecular mass, when we are calculating, we are taking the average molecular mass. I just told why we need the average. Now average molecular mass again are of two types. One is known as number average molecular mass. So let me write number average molecular mass, and then we are going to discuss the weight average molecular mass and their relation. So let's start with the number average molecular weight, or in short MN bar. It can be read like N1 M1 plus N2 M2 plus N3 M3 and so forth, divided by N1 plus N2 plus N3 and so on. So I can take in a short summation of Ni Mi divided by summation of Ni. So this is the working formula to calculate the number average molecular mass or number average molecular weight. Very soon we are going to discuss one or two quick numerical on that point. Now after the number average, then we go for the another one, that is called weight average. Okay, weight average molecular mass or weight. In short, we are writing MW bar. Okay, and the formula is N1 M1 square plus N2 M2 square plus N3 M3 square plus so and so forth, and then we can take N1 M1 plus N2 M2 plus N3 M3 and so on and so forth. So in short, we are going to write summation of Ni Mi square divided by summation of Ni Mi. Why we are taking summation? Because we are considering all of them together. Okay, all of them together. It may be 3, 4, 5, whatever. Now very quickly, what is Ni and what is Mi? Ni is the number of polymer chain with Mi molecular mass or molecular weight. So this is called Ni and Mi. Like if I say very quickly, I'll tell you one example, then we'll understand better. So now continuation of the story. We started what is polymer, we discussed what is monomer, and then we discussed when the different number of monomers join together give you polymer. When different number of monomer join together to give a polymer, we can expect of different range of molecular mass, so that we have to take the average. And I said the average in case of polymer are of two types. One is the number average molecular mass and the weight average molecular mass. Okay, very quickly, when I give you an example, you understand N1 and M1. What I said N1 and M1, quickly, if I say suppose 10, okay, where I can write here. Okay, I can write here quickly that suppose 10 molecules have molecular mass 100, 20 molecules molecular mass, let's say 300, 30 molecules molecular mass, let's say 400. So it means this is my N1 and this is M1, this is N2 and this is M2. Okay, this is N3 and this is M3. So this is how it will be given in the numerical. Okay, it will be clearly given in the numerical that how many, what is the distribution of the molecular mass and how many chains are there. We are going to do quick numerical for that. But here, one important parameter we are going to discuss. But always remember, the value of weight average always higher or greater than the number average. Okay, this is very, very important, because when you calculate the number average and weight average, you always need to be careful that the value of the weight average molecular mass or the weight average molecular weight always be higher than the number average molecular mass. Okay, so now let us go quickly for our one more next parameter. One of the parameter there we are going to discuss, that is known as Polydispersity Index, and then we will have a quick numerical. So now, as I said, one more parameter, and that is highly important in terms of numerical, and that is known as Polydispersity Index. In short, it is known as PDI. And polydispersity index is the ratio of the weight average molecular mass to the number average molecular mass. Now here we need to understand, since that value of MW bar is always higher than the value of number average, so it means that value of PDI must be more than 1. That is another cross check point that we need to understand. Okay, so polydispersity index. Now someone quickly asked me a question like what is the importance of the PDI? Now PDI talks about the distribution of the molecular mass of the polymer chain. Okay, that is a very correct statement, that PDI value give you an idea about the distribution of the molecular mass of the polymer chain. That is the importance of the PDI. Now, as I said, we have a quick numerical. Okay, we have a quick numerical to understand this. In a polymer sample, 20% of a molecule have molecular mass or molecular weight 20,000. So can I consider that value of N1, I'm just writing a little bit from this side. A value of N1 is 20 and the value of M1 is 20,000. And then 30% of molecules have molecular weight 30,000. Okay, it means the value of N2 is 30, value of M2 is 30,000. Okay, it is 30,000. And then remaining. Now what is the remaining? Because we are talking in terms of percent, so total must be 100. Okay, now since 20 and 30 is 50, subtract from the 100, remaining will be the 50. So N3 value will be 50 and value of M3 is 60,000 is given in the numerical. I said in any given numerical you will find all these values. ये सब दिया रहेगा. Only thing we have to just put into the equation, we have to calculate quickly. Now what they ask for? They ask for the number average molecular mass. So let's calculate. Mn bar is equals to, we can write that N1 M1, N2 M2 and N3 M3 divided by N1 plus N2 plus N3. Now let us put the value. Value of N1 is 20 into 20,000 plus 30 into 30,000 plus 50 into 60,000 divided by 20 plus 30 plus 50, and if I am not wrong, this value will come 43,000. Okay, correct me if I'm wrong, so please you can cross check with your calculator. So 43,000. Now this is the number average. So this is the first answer that we got. So now we go for our second calculation, and that is MW bar. Okay, MW bar is the weight average, and you know the formula: N1 M1 square, okay, N2 M2 square plus N3 M3 square divided by N1 M1 plus N2M2 plus N3M3. We have simply substitute the value. You will get this value close to 50,000. I'm not putting the value again because I have shown once. Okay, I don't want to see that. You just put the value, do the calculation with the help of calculator, you will get this answer, I suppose. Now one more thing I have to calculate. So we are done. One more thing, like it's PDI. Okay, what is the Polydispersity Index? Okay, I said that PDI is MW bar by MN bar. So just put the value 50,000 by 43,000 and this value will come 1.16. Okay, 1.16. This is the simple way by which we can solve the numerical. Now let us the cross check point. As I said, there is some cross checking point. The first one, you can see the weight average value should be more than number average. Look at here. Here we are getting the number average 43,000. Here it is 50,000, means it is correct. Second cross check point, PDI value should be more than 1. Here also you can see the PDI value we are getting 1.16. It means that we are in a right direction. So this is the cross check point, because these numerical are very simple and okay, we should not do any kind of silly mistakes. So with this we are done with the number average and weight average discussion. We'll go to our next discussion. So let's continue with our next point of discussion, and that is also very important with respect to the exam. You can see that is called additives or compounding of plastic. What does it mean? Why we need to add something into the polymer? Remember, polymer is basically a granules. We need to process, then only we will get the desired product in the plastic, desired property in the plastic. Okay, so in order to get a beautiful color, look at this pen I am holding. It's a plastic material with have a beautiful red color. With this one have a beautiful blue color with a very glossy finish. Okay, so these are the plastic material. But polymers are basically coming like a granules, just like a sabudana. Okay, we have to process it. Now while processing, we need to add some of the things in order to get the better property. So let us talk that what are the additives that we need to use, or we need to use while synthesizing or preparing the plastic to get the desirable properties. So the first one is the resin. Okay, resin is the main component of the plastic. It holds all other ingredients. Okay, and the majority of the property of the plastic depend on the resin. What kind of resin you are using? If your resin is water resistant, then the plastic should be water resistance. If the resins have a high thermal stability, then the plastic also showing you the high thermal stability. The mechanical property. So resin is the main ingredient in the plastic, and it should be. And how much? Almost 30 to 100% the natural or synthetic resin we can use. Okay. If I go for the second one, after the first one, we're going for the second one is the fillers. Initially, I can tell you, when initially people adding the fillers, okay, you can see the example, mica, talc, chalk, sawdust, they are very cheaper they're very cheaper, right? Very cost effective. So we are adding into the polymer in order to reduce the cost of the end product. But eventually we found, because we are adding inorganic material into a polymer matrix, so what happened? The thermal stability increases, the mechanical strength increases, the hardness of the sample increases. Okay, these are the another advantage of adding fillers. At the end of my discussion, I'll show you, sometimes if I add the filler which is conducting, it will make the entire product conducting. Okay, we are going to discuss at the end of this video. Now the third point is the plasticizer. Now why plasticizer? From the name you can understand that plasticizer which increases the flexibility of the polymer. Suppose this polymer, if it is very hard, it will have much more chance of brittle. The higher the hardness, higher is the brittleness. But if there is a little bit of plasticizer is present, it makes the product little bit more flexible. It will give you more impact resistance. Now how this plasticizer work? Plasticizer we are using, you can see in the plasticizer we are using esters of fatty acid, we can add vegetable oil. Now how this plasticizer work? Basically the plasticizer reduce the intermolecular force of attraction between the polymer chain. Now if the polymer chain initially, let's say these are the polymer chain, they are come close to each other because of the intermolecular force of attraction. Now what the role of the plasticizer play? They are coming in between the polymer chain and keeping one polymer chain away from the other, so the intermolecular force of attraction decreases to some extent, which increases the flexibility in the polymer. That we need to understand. Now the fourth point is the lubricant. Now as I said, most of the plastic material, you can see the pen I am holding, and whatever the things you can see in the room where you are sitting, you can see around you, you can see most of the plastic have a proper shape, and that shape is, or the the outcome is coming because we are using some mold. Now while molding we have to melt the polymer. So the molten polymer or the melted polymer should have a proper flow property into the mold, and that is being taken care by the lubricants. So lubricant give you lot of property, like lubricant makes sure the flow property of the polymer, molten polymer into the mold, number one. Number two, lubricant making sure that the molten polymer should not stick to the surface of the mold. Okay, so it prevents sticking to the mold. That is another. And third one, what is more important, is the glossiness. It provides the glossiness in the product. So all these things will be provided by the lubricant, and as a lubricant we are using wax, soaps, etc. Going ahead with the fifth is the pigment. Now from the name you understand that pigment are responsible for the color of the polymer or the plastic. You can see the pen I am holding, which is a beautiful red color. This is a blue color. Now this color is coming from the pigments. In the pigments we can use like organic or inorganic dyes. Okay, that is very common. Then we are using the catalyst. Here we have to be careful. We need to be careful because catalyst we are using only for the thermosetting polymers. Okay, only for the thermosetting polymers we can use the catalyst, not require for the thermoplastic polymer. Thermosetting polymers require that catalyst. Why? Because thermosetting polymer undergoes polymerization. So in order to increase the polymerization process, we need to add the catalyst. The example frequently used catalyst is the hydrogen peroxide, sometimes the metallic catalyst we are also using. And the last one is the stabilizer. I think this is most important. In the name of stabilizer we can use the lead chromate, lead silicate, this kind of stuff we are using. Now why the stabilizer? From the name you can understand stabilizer means which can stabilize something. Now what is the need of stability? I said that for the molding we need to melt the polymer. Now polymer in the liquid state are very much reactive to the atmospheric oxygen. What will happen if they react with the atmospheric oxygen? Either they will go for a degradation or they will change the color. In both the cases, both the situation is not desirable. We don't want to lose the color of the basic polymer, neither we want to see that polymer chain undergoes degradation. So we need to apply a stabilizer in order to get a better product. Okay, so that is the reason we are using the stabilizer. So these all are the additives or the compounding of the plastic. Okay, now we go to our next segment for the discussion. Now we are going to discuss what is the effect of heat or temperature on the polymers. As you all know that polymers are very sensitive to the heat or the temperature. If we increase the temperature, the property of the polymers varies. But here we need to know the polymers are of two types basically. One is the amorphous polymer. You can see amorphous polymer where the polymer chains are randomly arranged. On the other hand, we have a semi-crystalline polymer. Semi means half. Crystalline, you can see some of the segment here, you can see this segment is crystalline because it is properly arranged. When the polymer chains are properly arranged, they give rise to a crystalline nature. Okay, they give rise a crystalline nature. So amorphous polymer have very good impact strength because they are very soft, but they does not give you engineering property in terms of higher mechanical strength. But on the other hand, if you see the semi-crystalline polymers, because of this crystalline nature, they are giving you the melting point, surf melting point, and also they are giving you better engineering property in terms of strength, the thermal stability. So these are the semi-crystalline and the amorphous polymer. The example of the amorphous polymer I can tell you is a polystyrene or thermocol. On the other hand, semi-crystalline polymers are very much PP, PVC, like polypropylene, polyvinyl chloride. They all are the example of the semi-crystalline polymers. Now, semi-crystalline polymers have melting point. Amorphous polymers, they don't have melting point, but both of them have the glass transition temperature Tg. Okay, both of them have a glass transition temperature. This polymer have a glass transition temperature. This polymer also have a glass transition temperature, and that is the reason that glass transition temperature we can consider as a characteristic value of the polymers. Now the question is coming, what is glass transition temperature? Now you can see I have given you the definition of the glass transition temperature. The definition is, it is the temperature, lowest temperature below which the polymers becomes hard and brittle. Very hard, and we can understand if the hardness increases, obviously the brittleness increases. So if I reduce the temperature, if I decrease the temperature, the polymers become very hard or glassy. Okay, but above, if I increase the temperature above the glass transition temperature, the polymer becomes soft and flexible. So here I am getting a very clear-cut idea. So consider this is Tg. Above the Tg, the polymer will behave rubbery. Below the Tg, the polymer will behave glassy. So that is the surf difference we need to understand. The glass transition temperature is very, very important to understand. Now, glass transition temperature, you understand, above which soft, rubbery, below which glassy. Understand. Now, glass transition temperature, characteristic value of the polymer, of all the polymers, no matter amorphous or semi-crystalline. That is the reason the Tg is so important. Now, we have to understand that what are the parameters on which the glass transition temperature depend. Okay, we are going to discuss that. Now, why we need this temperature? Why we need the temperature? You understand, the moment I am giving the temperature, it means I am giving the energy to the polymer chain to move. Okay, I am giving that energy to the polymer chain for the movement. Okay, now this glass transition temperature depends on certain factors. We will quickly discuss that. So now let us discuss, as I said, that glass transition temperature is very, very important parameter. So let us discuss that what are the factors on which the glass transition temperature value depends. Okay, let's start. So as I said that we are talking about the glass, the first point, chain length. So if the chain length increases, the polymer need more energy for the movement. It means the glass transition temperature will be high. So higher the chain length, if chain length increases, the Tg value will also increase. Second one, cross-linking. So we understand if there is a cross-linking between the polymer chain, it means polymer chains is entangled with each other. It means they need more energy for the movement. As a result, the glass transition temperature will be high. So cross-linking, if the cross-linking is high, the Tg value will also increase. The third one, presence of bulky groups. You think about your two hands is a polymer chain. Now if I give you two load on your hand, it means to move we need more energy. Similar to the polymer chain. If the polymer chain contains any bulky group, let's say phenyl group or benzene group, it requires more energy for the movement. So higher the presence of bulky group, the Tg value will also increase. Number 4, polar group. See, understand that polar group are always active. They active, not only active, they will increase the intermolecular force of attraction also. So higher the polar group, higher is the affinity, higher is the activity between the polymer chain. So it will again cause or lead to the higher in the glass transition temperature. Number 5, presence of plasticizer. I already discussed that what is plasticizer. Presence of plasticizer means plasticizer are there to reduce the intermolecular force of attraction. प्लास्टिसाइजर इंटरमोलिकुलर फोर्स को कम कर देगा. It means polymer chain can easily move. So it means the presence of plasticizer, okay, the presence of plasticizer, glass transition value will decrease. Okay, the glass transition value will decrease. Now the sixth one, intermolecular force of attraction. I don't think I need to discuss this again and again, because we understand if there is the intermolecular force of attraction is high, then obviously the glass transition temperature will also increase. Yes or no? Okay, glass transition temperature will also increase. Now the last point is the coil nature of the polymer. So what does it mean? Some of the polymers like rubber have a coil-like structure. This is a coil-like structure. If the polymer shows coil-like structure, they can easily move. They shows the flexibility. In a result, the glass transition temperature will decrease. So very quickly you can understand the presence of plasticizer, Tg value decrease. Coiled nature, Tg value decrease. All other parameter, they increase the Tg value. That will help you to remember for the exam and to remember for long time. Okay, now we go to our last point of discussion very quickly, and that is the conducting polymers. So let us discuss the last point of this video, which is very crucial, and that is conducting polymers. You know, in the present day, the conducting polymers found a variety of application, either in terms of sensor, as a EMI shielding, like magnetic shielding, okay, EMI shielding. A lot of application we find in the conducting polymers. Okay, now this conducting polymers, is the polymer itself really conducting? Question is, very few polymers are conducting. Most of the polymers are insulator. Now, who are the polymers are conducting? The polymers with having a consecutive single bond, double bond structure, like I can show you. Okay, so we are discussing a very important parameters, conducting polymers with a lot of application in the field of electronics in the current scenario. Suppose one polymer contains this kind of structure, okay, consecutive single bond, double bond, single bond, double bond in the structure, in the backbone of the polymer chain. Those kind of polymers are conducting by their nature. It means they are intrinsically conducting polymers. Intrinsically, like by their nature they are conducting. So they are known as a intrinsically conducting polymers. But as I said, most of the polymers, they are not conducting, but we impart the conducting or the electrical nature in that polymer, okay, externally. So they are known as extrinsically conducting polymer. Okay, extrinsically conducting polymers by the use of conducting filler or blending. We'll discuss very soon. But I think we need to understand that when we said the polymer is conducting, because conductivity again are of three types. We can say conductor, okay, semiconductor, and the insulator. Remember, anything less than 10 to the power minus 7 Siemens per centimeter is considered as an insulator. In the range of 10 to the power minus 7 to 10 to the power 2, known as a semiconducting range, and beyond that, more than 10 to the power 2 is always considered to be a conducting or metallic conductor. So, but most of the polymers, as I said, they are insulators, so we can play in the range of semiconductor only. Okay, and that is the reason this conducting polymers found a lot of application. Now, intrinsically conducting polymers, as I said, they are conducting, but their conductivity is not up to the mark. So we can enhance their conductivity by some doping. Now what is doping? You can see I have used that word p doping and n doping. What is doping? Doping means the presence of some foreign elements. So what we'll do, we'll incorporate some foreign elements in the polymer chain. That mostly we are using either group 1 element or group 17 elements. Why group 1 and group 17? Group 17, if I say group 17 elements like fluorine, chlorine, bromine, iodine, in their electronic configuration, you always know there is one electron less to fulfill the octet. Like all the polymers having the electronic configuration NH2NP5. Okay, NH2NP5. So outermost cell में 7 electron है, they need one more electron. So they always act as a Lewis acid. We know that any substance which accept the electron is a Lewis acid. The substance which donate the electron pair is a Lewis base. Now it means in the polymer chain, if I dope, now you can see in the polymer chain, suppose I dope iodine, I minus. So what will happen? Iodine will take the electron from the polymer chain because iodine desperately need one electron. They act as a Lewis acid. Okay, so what will do? They will take one electron from the polymer chain and they create a positive environment in the polymers. They will create a positive thing. So by this way, they enhance the conductivity. Now, since we can see in the polymer chain there is a positive, so it will known as a p doping. Okay, that is known as a p doping. Now what is n doping? N doping most of the times we are done with the group 1 element, like you can say lithium, sodium, potassium. Okay, if you see in their electronic configuration, like lithium is 2,1, but sodium is 2,8,1. Okay, similarly they have one extra electron in their outermost shell and which they want to donate in order to enhance their stability. Because they want to donate the electron, they act as a Lewis base. Okay, now what happened? Suppose in the polymer chain, again I am drawing one more polymer chain quickly with having a consecutive single bond, double bond structure. Now suppose I am adding lithium here. I am adding lithium. So what will happen? Now lithium will give one electron to the polymer chain. Okay, one electron to the polymer chain. It means it will create a negative charge on the polymer chain because negative, so it will be known as a n doping. I hope this discussion will make anyone very easy to understand that what is the effect of doping, at the same time why this is known as a p doping, why this is known as a n doping. When in the polymer chain there is a positive charge developed, it is known as a p doping, which can be done with the help of group 17 element. In the polymer chain we can create the negative charge by doping with group 1 element, and the basics behind, the reason behind is also discussed. So this is known as a p doping and n doping. Now, intrinsically conducting polymers. While discussing the additives, okay, in today's video, I told you at the end of the discussion, we are going to talk about the conducting filler. Now, conducting filler, who are the conducting filler? There are many conducting fillers are available, like graphene, like carbon nanotube, like carbon black. They all are the example of conducting filler. Now, it means in any extrinsically conducting polymer, let's say polypropylene, PP is purely insulator. Now if I add carbon nanotube into that or the graphene into that, the conductivity of the composite or the plastic will enhance. Not only enhance, if I add more and more carbon nanotube, more carbon black, the conductivity will increase. So we can play the, or we can tune the conductivity range also. So that is called extrinsically conducting polymers. By use of conducting filler, we can enhance the conductivity of the extrinsically conducting polymers or extrinsically polymers. On the blending, what is blending? Blending, if I blend the conducting and non-conducting polymers both, if we blend them, then also we can increase the conductivity in the polymers. Okay, so this is how we can incorporate the conductivity in the polymers, and this is all in the conducting polymers. So with this we are concluding today's discussion, and I hope at the end of this video each and everyone will understand the polymers very well, because we discussed the basics and fundamental of the polymer in a very easiest way. Okay, so I hope it will helpful for each and everyone. Thank you very much. Namaskar.